to create and design helicopter with assembly. Okay, in this project 2, we have completed 2 parts. One is our fuselage, main fuselage, and second one is our upper side fuselage. Okay, this one and this one, main body of the fuselage or body of this helicopter fuselage component is done by using our open VSP and by using 2D geometrical parameters. Okay, we have done with our part 1 and part 2. Part 1 fuselage, part 2 top fuselage. Okay, now today we'll be dealing with part 3, that is tail fin, and part 4 tail fin 2. Tail fin 1, tail fin 2. Tail fin 1, tail fin 2 in the sense this part. This is our first part, tail fin, and this is our second tail fin. Okay, this one or this one. So today we'll be completing this. If time permits, then we'll even complete this one. Okay. That is our tail plane. Okay. So here we have tail plane, and this is our tail fin 1, okay, and 2. With respect to that, whatever dimension needed for this tail fin 1 and 2, okay, so clearly I have mentioned here in this slide. Okay, tail fin 1, span, chord, root chord, tip chord, sweep angle, and aerofoil, which has to be used for this case. Okay, that is tail fin. To design this tail fin in the open VSP, we need our parameters, no? So that parameter I mentioned clearly. So we have to use this parameter, okay, wing design parameter, and we have to complete our tail fin 1, and similarly we have to do for our tail fin 2. Okay, and with respect to this tail fin 2 design data or wing parameter I have mentioned, and we have to use this, and we have to complete our tail fins, okay, for our helicopter. That is part 3 and part 4. With respect to this tail fin 1, we have top view, front view, left side view. Okay, so now what we'll do, we'll use our parameter and we'll complete tail fin 1, tail fin 2, and if time permits, then even we will complete our part 5 tail plane. Okay, this one or this one. We'll go to open VSP now. Part 1 done, part 2 done. Now we are on part 3, tail fin 1. So let's go to open VSP software. Here we have our software. Okay, we know that as soon as we double click on our software, we'll get 2 windows. One is our open VSP window, and one more is our geometrical browser window. By using geometrical browser window, we can add our component. Whichever component we will add, that will be our default component. Okay, for that default component, we have to use our geometrical parameters. Okay, so today we will be dealing with the tail fin. Tail fin, it's looking like completely wing, no? So which means we have to add our wing component. Okay, so I'll select wing. Just oh, sorry for that. Okay, we'll continue. Yeah, so as we know that we are dealing with tail fin, it's like a wing, so that's why in the open VSP we have to add wing component. Okay, so I'll select wing and I will add wing. Okay, so here we got a default wing. Okay, see here we don't need a symmetry part, no. So that's why what I will do, I'll come to X form and I will off the symmetry part. Okay. With respect to the plane XZ, I don't want any symmetry, so that's why just I will off this checkbox. Okay, I need in this form, so that's why I have off this checkbox XZ planar symmetry part. I have off. Now here we have our default values, so we have to use our design value. So span for our case tail fin 1 span is 1.55 meter. Okay, so we will use that span 1.55 meter, enter. Okay, so that is our span, and chord 0.511. Okay, chord 0.511 meter. Okay, we will use that chord 0.511, enter. Okay, yeah, done. So I'll just put on screen. Yeah, rest of the things no need to do anything, because as we know, if you disturb our span and chord, then automatically area and aspect ratio will get that value. So no need to do anything to area parameter and aspect ratio parameter. Okay, default whatever you got, just keep that is as it is. No need to disturb to area and aspect ratio, because we know these two parameter, so that's why no need to disturb any other parameter what we have in this plan form. Okay, that is area and aspect ratio. So directly now we will go to uh, next parameter what we have, that is root chord and tip chord, that we will enter in our section. Okay, uh, here other parameter I have not given anything, so that's why just I will go to section. In the section we have yeah, span, we know that it's 1.55 meter itself. Okay, and root chord I mentioned how much root chord. Root chord 0.7 meter and tip chord 0.312 meter. Okay, so we will use that root chord and tip chord value. Root chord 0.71, enter, and tip chord 0.312, enter. Okay, yeah. Any other parameter mentioned? Yes, sweep angle, that is 33.36 degree. Okay, 33.36 degree, that we will enter now here. Default sweep is 30 degree, so instead of this now we have to type 33.36 degree, 33.36 degree, and enter. Okay, so rest of the things no need to do anything in this box and all what we have. Okay, because I have not given any other parameter. Directly now we have aerofoil. Okay, so now we will go to aerofoil. Here we have the aerofoil. So default aerofoil is NACA 0010. Okay, so for our case also same aerofoil we need, so that's why I will not do any changes. Okay, because for our case tail fin aerofoil what we need, that is NACA 0010. Okay, NACA 0010 in the sense the chord is 0.710 meter, thickness to chord is 0.10, and camber 0% camber, and location of camber is 20% from leading edge. Okay, that is our aerofoil parameter. So same parameter we have here. Okay, NACA 0010. So let it be now. Let it be. No need to do anything. Okay, just now I'll come to surface and I will share this. Okay, and I will fit on screen. So here we have done with our tail fin. Okay, top view. view, front view, front view, and left view. Okay, so here we have this view. Okay, and this one, this one. Okay, so don't worry about view. Here it got changed left, front, and top. So now I'll just share this. I mean, like, I'll change the surface. Yeah, right ISO. Yes. So we have done with this component. Okay, this one, tail fin one in this is this one. We have done with this component. Okay, now what we'll do, we'll go to this component. Okay, tail fin 2. Okay, so we will complete that. So with respect to that design parameter I have mentioned here. Okay, tail fin 2 part 4 tail fin 2. Okay, so before that I'll just save this component tail fin 1. I'll go to file, save as. I'll just mention the file name, uh, that is our part 4 tail fin, sorry, part 3 tail fin 1, right? Part 3 tail fin 1. Okay, accept. So I'll just again I'll go to file, see here, part 3 tail fin 1 dot VSP3, which means successfully we have saved our file. Okay, now what I will do, I'll just go to file and new. Now we have to design new component, no? Tailfin, uh, tailfin 2. So to design this in the open VSP, just we have to go to file and new model we have to design. So that's why new. Okay, again we have to select the wing component, we have to add. Okay, and we don't need a symmetry part, so that's why I'll just off the symmetry part. Okay, and I'll use these parameters what we have. Span 0.79 meter, span 0.79 meter, and chord 0.53 meter, zero 0.53 enter. I'll just put on screen. Okay, and root chord, tip chord, which means I have to go to section. Okay, so here I'll come to section, span same 0.79. Okay, because here we have given that value, no? So that's why span you will get automatically 0.79. Root chord now we have to change. Okay, root chord how much I mentioned, 0.79 root chord, in the sense this one. Okay, this chord, and tip chord this one. So root chord is 0.72 meter and tip chord 0.34 meter. Okay, root chord 0.72 enter, and tip chord 0.34 meter enter. Okay, yeah, and directly now yeah, before aerofoil I have to even give the angle, sweep angle 28 degree. Okay, so here the default sweep angle is 30 degree, so we have to change this to 28 degree. Enter. Okay, yeah. So all parameters done, right? Now directly we have to go to aerofoil. Yeah, I'll come to aerofoil. Default we have same aerofoil NACA 0010. Okay, and here also I mentioned same NACA 0010. So no need to do any changes in the open VSP. Let it be. So directly I'll just now I'll share this. Okay, and I will take the right ISO view. I'll fit on screen. So here we have done with our that component. Okay, tail fin 2. Okay, tail fin 2 is done. So let's check all this view: top view, front view, and left side view. I'll go to view, top view. So here we have this one, top view. Okay, top view, front view, this one, which means this one. This one is our front view, and left view. Okay, so I'll just change this to none. Yeah, so here we have top view, this one. Okay, this one, and front view, this one, like this or like this. Okay, that is our front view. Okay, and left view, this one. Okay, so we have done with that component. Okay, now last component what we have for our today's class, that is tail fin 2. Okay, sorry, not tail fin. This is our this component. We have done with tail fin 1, tail fin 2. So fifth part, that is tail plane. Okay, tail plane. Okay, so part 5, tail fin. With respect to this data I have to give, no, that I have not mentioned here. Okay, no issue. So here a span for this case is 3.05 meter. Just all of you please note down this value which I have not mentioned. Chord 0.38281 meter. Okay, and root chord 0.36458. Chord 0.40104. Okay. Sweep angle, we don't need any sweep angle. By looking to this geometry, we can say it's completely straight, no? So there is no any sweep. So that's why sweep angle is 0 degree. Okay. And aerofoil, we'll take this 2. Okay, 0.22, which means thickness to chord ratio 0.22 meter. Okay, camber 0% and location of camber 20% from the leading edge. So we will use now we'll complete this just in a 2 or 3 minutes. Okay, so before that, let me save this. So this is our this part, tailfin 2. Okay, tailfin 2. So I'll go to file, save as, file name, part 4, tailfin, accept, and I will go to file, new component I have to design now. Okay, that is our tail plane. Okay, tail plane in the sense this component, this one, this one. Okay, or this one what we have, or this one. Okay, okay, so this one. Okay, that is our part 5 tail plane. So just we will go to open VSP now. In the we know that it's a wing, so that's why I just add a wing. Okay, we don't need a symmetry. Yeah, it's symmetry only, so let it be symmetry itself. Okay, because here we have complete section type. Okay, so let it be symmetry, no need to have symmetry part. Okay, now directly I will use the parameters. Span 3.05 meter, span 0.5, enter. Let's off this letter we'll use. So symmetry I have now, so that's why that I will now type values. Span 3.05 meter, span not span 3.05 meter. Okay, 3.05 meter, and our chord 0.38281, 0.38281, enter. And section, in the section we have to use root chord and tip chord. Okay, root chord 0.36458 meter, root chord 0.36458, enter. And tip chord 0.40, enter. Okay, 0. That is what we have now. 0.40104 meter. Okay, so if you are taking symmetry, then this span and other parameter it will become double. No, that way also you can enter. So, why simply complication? So that's why I just off the symmetry part and I just use the given value as it is. Okay, so we have that method also, this method also. Okay, so all parameters done, and sweep angle that is 0 degree. Here we have 30 degree, no? So just we have to change this to 0 degree, enter, because we don't need symmetry. Sorry, sweep angle. Okay, yeah. So see, it's completely that shape only. It on screen. Okay, and aero file Naka 0022 0022 aero file. So I'll just come to aerofoil and I will change these parameters. NACA 0022 means thickness to chord ratio 0.22 meter. Okay, and camber 0%, location of camber 20% from the leading edge. Okay, so we will input that value now. Thickness to chord ratio 0.222 and 3, camber 0%, and location of camber 20%. So yeah, we got NACA 0022. Okay, so NACA 0022 aerofoil that is added. Yes, now I'll just share this. Right, I see. So we have done with our tail plane. Okay, here we have our views. Okay, top view, front view, this one front view, and our left view. Okay, this one, and our ISO view, it's here. So this is our ISO view. Okay, this is our ISO view, this one. Okay, so now I will just go to file, I will save this. I will save tail plane. Okay, go to file, save as, file name, part 5, tail plane, accept. Okay, so we have done with our tail plane. So today we have covered tail plane, tail fin 2 and tail fin 1. Okay, so I'll stop here and we'll continue in the next class with our next component what we have, that is rotor back, main propellers, tail propeller, landing skid. So next class we'll do our rotor back. Okay, if time permits we'll go for main propeller. Okay, thank you to all. It's pandemic, be in home and take care of yourself. Yes, thank you.
Okay, thank you, sir.
Okay, thank you, sir.